And that is our dear friends at Thomson Reuters. Steve, it's you against the rest of the world.
Oh, the door's locked, yeah. Okay. Right, so good afternoon, folks. We're on the home stretch now, so just one more talk to go, and then we're done. So we're going to finish off with a look at Markush. So at Thomson Reuters, we've been curating Markush structures from patents for quite a while now. So we're going to just look first at how Markush is implemented into the ChemAxon world, and then just really look at an overview of what Markush can tell us if we just try and broadly analyse the patents that have Markush structures within them. So as I said, we've been at the Markush game for quite a while now. So the back file of Markush structures that Thomson Reuters has goes right back to the 1980s and 1970s in some cases. So it's a big set of data that we have available. This is created as part of the process that creates the Derwent World Patents Index, and so a well-known database of editorially enhanced patent information. And the editorial team that create the database, they redraw and store the Markush structures from the patents that we curate into our own file formats alongside the extracted specific compounds and the corresponding patent summaries, so English language patent summaries from the worldwide patents that are within the DWPI database. So we're capturing a lot of information, have done for a long time. Just a quick look at the countries that are covered within DWPI for Markush indexing. So there's around 28 or 29 of those now. So all the major authorities are covered. We'll see how these break down in terms of sort of number of patents issued just in a few moments. In terms of how this impacts into the ChemAxon world, so we've been working with ChemAxon now for a few years. So the Markush structure data is available to use within the JChem database tools. So access to the full Markush data set with those specific compounds, and within those, and additionally with those DWPI patent summaries, give access to the full set of data that we can offer in this area. So this data can be searched, enumerated to generate specific compounds from the Markush, which can then be integrated into other systems. So benefits of having this data in the JChem system. So there's a side-by-side display of the Markush structures with the value-add patent summaries that I mentioned. It saves time in terms of looking at the results of a Markush structure search. So quickly to pick out the most important patents for a particular set of search results. And the enumerated structures from a Markush are in those standard formats, so opens up the possibility of integration with other data sets that you might have. And the typical use cases that the data is used for is the sort of traditional searching by the intellectual property folks and other users, such as screening against existing IP, potential use in white space identification. All of those things are kind of opened up for the possibilities for using Markush. But really, for the rest of the program, I just thought I'd show you a few analyses of what the Markush data can tell us, really looked at from a broad perspective. So we're seeing lots of very, very narrow things about particular patents, particular records. The rest of what I'm going to show you is really a broad overview of what I found by just doing a few simple analyses of the sort of global patent data in a few cases. So to start with, I looked at the patents that had Markush structures in them, published in 2012, and we can see how that breaks down into the number of patents in the pharma industry and the sort of non-pharma chemistry. So it's my two major divisions there. So you see the overwhelming majority of these patents are in the pharma industry, more than 8,000 last year in the pharma space, and 3,700 in the sort of non-pharma chemistry space. And we can see how these break down firstly in the pharma industry. So just broken down really simply by number of patents issued by these, or number of patents applied for by these companies. So all of the sort of big players in the pharma industry given there. So you see quite extensive patenting activity, so more than 100 per year from quite a few of those big companies. So regularly issuing patents with Markush structures in. We just move along to see in that pharma space where those patents are appearing. So overwhelmingly, the largest is the USA, as we may expect. So that's around 40% of the total. So followed by China, followed by Europe, just as the green space there, followed by Japan, and Korea, and India, and then just a small amount of others. So it's very principally segmented like that, with the USA at the top, China issuing very large numbers of patents really in all areas now, but a lot of those do have the Markush structures in. And moving over to look at the chemistry space, as I'm calling it, so the non-pharma patents that have Markush structures, we can see the top companies there. So again, 100, up to 100 or more from the top companies there. And if we look at the breakdown according to territories again for that chemistry space, we can see it's slightly different. So Japan has got the highest number there, around 30%. Same for China, with the USA just down in third place there. So there is a shift between the pharma space and the chemistry space. Just looking at the numbers of patents issued with Markush structures in there. So Japan much stronger in the sort of pure chemistry space compared to the pharma space. So it's probably the major difference there. So the next thing that I looked at is just a case study. So for a particular chemical substructure or fragment, I just wanted to see what the Markush data could tell us about where those patents are appearing, when they were applied for, who was applying them. So I said, just looking through a number of marketed drugs, I noticed this fragment was appearing in a few of the ones that I saw. So I decided to choose this for my case study. So we'll look at the companies issuing these patents and the time frames involved and what those drugs are claimed to actually do. So let's go ahead and look at this. So this is now looking at the whole of the time frame of the database, so not restricted to 2012. So this is just looking at everything we've got in the data on this particular fragment. So back to 1988, I found 122 patents that claim new structures that contain that fragment. Okay. And just look at a few examples first. So we've got some patents that claim some specific compounds that have that fragment, and then a few that contain the Markush structures. So the pointer. Whoops, no, that's not the right one. Whoops, excuse me. So there's some that contain a specific compound, some contain Markush structures with those R groups, or there's an X group on the right-hand side there that the patent will then indicate what the actual definitions of those are. So those are sort of typical Markush structures containing this particular fragment. So we can see issued in various different territories, China, for example, there. And looking at a breakdown of which companies are most frequently patenting for that particular structure, we can see it's Merck, with a few of the others mentioned there as well. So this again is looking back through the whole of the database to pick out those frequently occurring companies in this case. So Merck very active and very interested in this particular chemical fragment. Looking again at how that's broken down, obviously with Merck being at the top there, no surprise that the blue piece of pie there is from the USA, followed by Europe and Japan. And looking at when these patents have actually been applied for is actually probably the most interesting of the lot of these. So this is just time along the bottom there. So starting at 1988 on the left and 2012 on the right-hand side there. We can see there's two main peaks there. So there was a big peak of interest around the early 1990s for this particular chemical fragment. not much around the turn of the century, and then a renewal of interest for whatever reason. So, did try to find some further information about why that might be so, but anyone's any idea, I'd be interested to hear as to what happened around these peaks to sort of set off that interest again. So it's a good example of what the just a simple breakdown of the patenting sort of landscape can show you about really the patenting activity around a particular structure. So was picked up again in the early part of the century after not much activity around that period of 1999, 2000, etc. So that's something I thought was quite useful to show. So in terms of those 122 new molecules, what were the activities claimed for those? So the DWPI data, as well as capturing the structure, has tags for the different types of pharma activity. So we can see a lot of those are related to the sort of coronary system, cardioactive, etc., hypertensive. But there's a few other different ones as well. So eye preparations, anti-inflammatories. So there are various different activities specified for those particular drugs. Of course, you may notice the totals there are much bigger than 100%. So of course, the patents do tend to claim a little bit of a wide list of activities, but we see that those ones are the most frequently occurring. And then just drilling down a little bit more into those patents from Merck. So just to give us an idea of who the top inventors were. So as well as the structure data itself, there's various other pieces of data that we capture for all of these patents, so we can see who are the actual people who are most active within Merck in terms of whose names are on those patents. So we can see who are the sort of key players in terms of individuals who are interested in this area. Okay, so that was just a brief overview of what Markush can tell us in terms of sort of drilling down into looking at the companies involved in these areas, which countries we find most patents from, looking at those trends in terms of the sort of trends across time in terms of when particular fragments became more popular for whatever reason. So there's plenty in there that the data can tell us, as well as the pure chemistry. So that's where I finish. So I'm happy to take your questions.
Very good.
Yeah, this may be wrong, but the only place I've seen that pattern is renin inhibitors across time. So any chance that substructure was in those sets?
I didn't look at them all individually, so I don't know which individual patents were there. There's one or two drugs in there I know for certain, but I'm not sure exactly which ones are in there.